Why, hello, calculates. It is really hot out, so tonight we'll be doing our calculus outside in the backyard. So we're discussing chain rule today, and one way to help you is a little device known as Doubter Dinner. You're probably saying, what the heck does that mean? Well, this means the derivative of the outer, and this means the derivative of the inner, so Doubter Dinner. So when I look at a function where I'm doing a composition like f of g of x, what I want you to do is I want you to circle the innermost one. So here, the innermost is g of x, and that acts as kind of a bubble. And so we're going to ignore the bubble, and I would say, how do you find the derivative of f of bubble? So f of bubble would be f prime of bubble. But at the moment, if we take a second peek back inside, we can see what's inside the bubble. And that's the derivative of the outer. So we started on the outside of the bubble, and then we want to work on the inside of the bubble. Well, if now I look inside the bubble, I say, how do I take the derivative of g of x? And that, of course, is g prime. And so that's my definition for chain rule. And we're going to think of this as if I were to put an M&M in your mouth and I did not let you chew on it, what would you have to remove first in order to get to the center? Well, the outside. And then once you manage to get the outside to dissolve, then you would dissolve the inside. So you have to kind of figure out what's the chocolate on the inside and what's the shell on the outside. And the chocolate on the inside is like the bubble. Okay, so now when I look at this first example, I want to know what's in the bubble. So I see that something is being raised to the fourth power. In other words, if up here I just had x to the fourth, I'm pretty sure, I'm confident that you would say, oh, the derivative is power down and decrease that power by 1. So, same thing is true on this. We want to power down and decrease that power by 1. And that's all the stuff on the outside of the bubble. And now I'm going to look on the inside of the bubble, and I'm going to ask, how do you take the derivative of the inside of the bubble? Well, if I look at the inside, I would power that down. So 6x now to the first. I don't really need that first, so I'm going to erase it. And then plus 0, but I don't really need that 0, so I'm going to erase it. And then I would simplify this if I could. So I see the stuff that's outside the parentheses. So that 6x and the 4. Of course I can put those together, because this is all multiplication after all. But I definitely do not want to have to cube this parentheses, because that would take a bit of work. So there is my first derivative. And again, I started with the outer, so that 4, and I powered it down, and then I worked off of the inner. Okay, so the next one. Well, first thing I like to do with the radicals is I like to rewrite them as exponents, because I'm really good at powering down. So this would all be to the 1/2 power. And so if I look at what's the inside, what's the chocolate? Well, this would be the chocolate. And so the outer shell would be out here. So I'm going to start with that outer shell first. So of course I have to power down. And I get a new exponent of -1/2. And then I have to take the derivative of the inside. And so for each term on the inside, I'm going to take the derivative. And then I'll simplify by putting the 1/2 with the 2x minus 2 and moving the negative exponent down. And of course I have the option of rewriting that inside the radical if I want.